have to cut this part of the broadcast window. I just want like. Okay, perfect. No. Okay. Hello, test test. Okay. No, I'm going to be projecting. Thank you everyone for coming. We're gonna get started. I decided to start 5 minutes late so that folks had time to eat and not feel the need to eat in this room. If I have connected to the screen now, I think I should be able to broadcast here. Is this gonna work? I don't know how this thing works. Oh, perfect. Okay, I apologize for the delay. Oh, I thought it would be the same for both. Does it look? Okay, and that one's also on. Good. I just don't. Can everybody see the screens? Okay. So I'm also going to. I'm going to send a link. Okay. I'm going to edit. I sent out a message earlier today in the academic events channel, a ping to remind folks that the event was happening. I'm going to edit that message with a link to a PDF document. Okay. And so you can go to that link and look at that document, and it will have some of the things today. But most of that's just in case you want to look at that after. Most of everything we'll need today is going to be on the screens here. We're good still. So we are also live streaming to YouTube. So keep that in mind. So if you ask a question, you might get picked up on the mic here, but probably not. I mean, you know. Okay, everybody can see this. Looks good. Looks good. Okay, perfect. So thank you everybody for coming. This is the first LaTeX workshop. The next one will be happening next week in this room, same time, on Tuesday also. So I wanted to get started. So I'll send out that link. So who here has, what is the general level of familiarity with LaTeX? Because we're assuming 0. I'm just curious. Medium? What's medium like? Okay, typing in a Word document. Okay, that's good. That's pretty much all you need to know, I think, to make a lot. Well, so today we're going to be going over like how to make a document, what it is, and how can you get started using LaTeX. But then we are going to be getting into some of the more important things to know, like how to do math typesetting. Okay, so that's going to be very important for you to know. If you're going to be using LaTeX, the most common use is for like a lab report or a problem set. And in any of these cases, LaTeX can be a great tool for representing math very easily. Okay, thank you, Ivan. Ivan's taking some pictures here. Is everybody here is okay with being photographed? I think so. Yes, good. Okay.
If not, you can always send it to.
Ivan, it's okay if I send out that notes for.
Yes. Oh, sure. I think it's actually on the GitHub, not on my GitHub, but on the GitHub blog. There's an update.
Okay. Oh, okay. I'm just. See you. Okay, so the notes from the workshop are available in the academic events channel. It's the most recent event in the academic events channel. This is Ivan's GitHub. So if I think he has some other cool stuff you might want to look at, but for today. So getting into it. So like I said, it's very useful to typeset problem sets and lab reports. But I think, like, what is LaTeX? Does anybody know to answer this question? What is it exactly? Yeah. Yeah. Mm-hmm. I think that's kind of what's important, is that, like, other it's essentially, in some ways, it's just a piece of computer. It's a computer tool that lets you make a PDF. But how is it different than Microsoft Word? How is it different than Google Docs? Well, LaTeX, like you said, I mean, what is it actually? It's kind of nebulous. There's a lot of parts. But LaTeX at the core is a programming language. And the way that the programming language works is you're not just telling the computer what to do exactly. You're not saying, make this object, increment this variable, add these numbers. You're telling it, put this piece of text on the page, make this math equation, write it out on the page right here. It's very specific. It's a programming language which specifically encodes instructions for the computer on how to create a PDF. And because it is a programming language, it has all the same advantages and disadvantages of any other programming language, like Python or C, in that it is extremely specific. And so for things like a lab report or a problem set where you want to be very specific in your mathematical notation, LaTeX is very useful. So how do you, once you have this code written, then what do? You use a LaTeX compiler. So a LaTeX compiler is a computer program which takes LaTeX code and then turns it into a PDF. Today, we're going to be using a LaTeX compiler and development software called Overleaf. It's on the browser. Very easy to use. Now, there are many other compilers available online, and almost every single one of them also has tools which allow you to write your own LaTeX code to a better degree than if you were just putting in a .txt file, which would be, I think that would be impossible. I mean, that would be very difficult. Like with any programming language, you don't want to code like that. But the main thing that the compiler does is it takes the code, as I said, and it turns it into the PDF. And there are other compilers that we're not going to be using today, but which could be used, which I think I use one called TechMaker, which is available on Windows. There's also TechShop and so on and so forth. There's many others. Pretty much anything you want to know about LaTeX that isn't covered today, such as what LaTeX compiler is right for me, you can find by Googling. So I'll keep that in mind. So today, let's go on to Overleaf. So I have here an Overleaf file. Everybody can you go to the Overleaf website? It's just overleaf.com and log in. Okay, I'm going to go to the home page here. So this is what you should see when you go into Overleaf. You guys see on the computer there? We're not going to get straight into programming. I just want to show people before we get started in terms of, like, how do you write out what is the process, what is the logic for the programming language. Just want to get people situated with the Overleaf website. So everybody good? Find that website. Anybody having any difficulties? I think you can log in with Google. It's pretty well integrated. And what does it look like? I don't have anything in my account. So what does it look like if you go just like splash screen, like right when you open it? It just says workshop, okay. You made that, I assume, yeah? The document there? Oh, that's good, that's good. Yeah, it's pretty intuitive. Like, it's got a pretty good user interface. So this will manage all of your files. So any file you want to use, which you want to, so this could be, obviously the main ones is the .tex file, which is a file which holds LaTeX code. like LaTeX code, like the equivalent of a .py file, right? It'll store those virtually, right? So Overleaf also has a little bit of storage, and it'll also hold like images, which you might want to attach to your document, and we'll get to that. Sorry, did you have a question? Oh yeah, so perfect. So this is exactly so. Unfortunately, I can't show this page on the TV. I don't have, because I've used Overleaf before. But yeah, so you just want to go create a new project, and you can just go blank project for now. But there's tons of samples on Overleaf, which is useful if you're writing a lab report. Although usually, I think for lab reports, your labs will give you an Overleaf, or like I took. You can see here I have a ton of MAT 237 problem sets on my Overleaf. So they'll give you, like MAT 237, the teaching team, they give a Overleaf or a .tech sample, file so you can write in. This is a pretty common thing to do. Okay, so getting into it. So we'll get back to this in just a moment. But first I want to talk about how, so I kind of went over this stuff, right? And we're in setup. So we're all opening up. Now, I've already discussed this kind of, but so we'll get back to this in a moment. But at a basic level, there are two ways of interacting in the language. There are two ways of drawing things onto the PDF in the Python, or sorry, not in the Python, in the LaTeX system. Okay? So, should have erased this beforehand. There are commands and there are environments. Whoops. Pretty much everything you want to do is going to be through one of these two types of commands, or one of these two types of inputs to the LaTeX language. Okay? So, we'll get started. A command is something which draws something to the screen immediately. So, for example, if you go to a blank document and you type, what's an example? Just start typing. Just write the word text, okay? You just write a word, in a sense, that is a command. You're just drawing something to the screen, okay? And what is an environment? An environment is a special section of your code in which you tell the computer, I'm going to start typing in the environment. You begin an environment explicitly. Python will, or I keep saying Python. LaTeX will take, it'll see you start an environment and it'll see you end an environment. And within the environment, there will be different rules applied, okay? So what does that mean? For example, I think the simplest environment is the $$ environment. So if you just type $$ into your LaTeX, and then in between the $, you start typing. Let's say you do $text $, okay? So you should have, let's say, text, and then you press enter a couple times to like start a new paragraph, and then you press $text $. Let's see what happens when that is done. Does anybody have it? I'll do it. I'll do it for the TV. Okay, let's see. And you guys follow along at home. And as I'm speaking, obviously I'm going quite slow. So you can do other stuff if something occurs to you, but Okay, so I have written here text, and I've written here text. Does anybody see? So I'm zooming in on the PDF, right? But in general, I only have two things here on the page. And we have text and text. And this one? Yeah. I don't think, that's all I can do. I can't like have it. So I just written here, it's exactly what's on the board, although I understand this is not the best marker. So I'll start using this one now instead. So what is happening here? As you can see on the TVs, why is text, the first one, normal letters, and the second one is like weird kind of mathy variables? So the $ environment is math typesetting, okay? So if you start writing in here, it will think you're telling it a math equation, and it will draw it to the screen in terms of math variables and text. So if we go, for example, I don't know, example, actually, yeah. Let's say we just have x equals 4, x equals 4. You can see here, I've written this to the screen. And then I've done a new line twice. And then I've written that. And this is representing this as a mathematical equation, and it's just taking this as plain text. Okay, so this is pretty simple, but in general, what you want to take away from this is if you want to do something where all of your input is going to be treated as a separate class than the normal case, you're going to want an environment. So if you want to make a table, it's going to be an environment. If you want to draw out like a multi-line set of equations, it's going to be an environment, and so on and so forth. So that's all very good. So now, or even if you want to have like a section of your document, okay, dedicated to its own thing. Well, that one's a command, somewhat confusingly, but you know, you kind of have to get used to it. But all right, so does everybody understand this? That's all there is to it about environments. Now, I want you to look here. What is our program? All we have here, we have 3 lines of code now, and it's just, oh, you have to have something in it. Yeah, okay, I wish you didn't have it. It should be able, you should be able to make a blank screen, but okay. LaTeX wants me to put. So I have 4 lines here. We have document class article, begin document, end document. What does this mean? So document class is a command defined at the beginning of every LaTeX document. It tells you what sort of rules are going to apply to the entire then /begin document and /end document. That's an environment in which you write out everything which will be printed to the page. So notice that actually everything that we are printing to the page in LaTeX is in an environment. So all commands occur within environments except for commands which aren't printing things to the screen. What does that mean? What commands aren't printing things to the screen? We will get to this later, but there are some. So at first, now, okay, so we've gotten through the basics. We know what begin document means. Document class article is just the most common document class. There's other kinds. You can use the report class if you're interested. I think Ivan will speak about it at the next workshop. He uses the report document class. I don't know why. Everybody uses article. I use article. Doesn't really make a difference. And so you can Google also, but just to keep it moving and to keep it on pace, we'll forego specifically what other document classes exist, and we will just speak about, in general, the article. And if you want to look into the other ones, you're available too. Okay. But in general, it doesn't make a huge difference that I know of. I don't know. I don't really use any other than article. So let's say now I'm in LaTeX and I want to start typing. The first thing I might do is to write a section, okay? So this is a useful command which I'm going to say, and I'm going to just say introduction. Okay. And now we can see on the screen, notice, Notice I didn't write the number 1, okay? So when you use the section command, I'll write it out. Notice this is a backslash. All the commands in LaTeX use the backslash. Oh, I have not written a backslash. Backslash goes this way. Section, and then it's the curly brackets, introduction. But that's just what I've put. That doesn't matter here, this stuff. You can put whatever you want in the curly brackets, as long as it's not going to mess it up. Normal text will always be fine. So, notice the section command doesn't just print out whatever you put in the curly brackets. It also puts the number. And it keeps track as you go through the document. So let's say I go introduction, and now I'm going methods. Let's say I wanted to write a lab report. Then it will print out number 2, methods. Okay? And so let's say I didn't want to draw the numbers. I will put section star. That is the command. And then it just prints out. Notice also if I have section star introduction section methods, then section methods has the 1 next to it. Okay? Just useful to know. I don't like the numbers. I like to have my own numbers. So I usually put the section star. Totally up to you, but that's something that folks should be aware of. It's a useful command to know. Okay, now let's get into it actually in terms of writing text. We have our introduction section, and then I want to put, hello, my name is Marty, and I'm going to put, it should be noted also that you guys have probably seen this, I forgot to say, but every time you write, you have to hit compile to make it appear on the PDF, okay? So this is really what I was meaning earlier. Like LaTeX, the thing on the left, is the code, and then Overleaf also incorporates a PDF drawer, okay? Like something to turn the code into a PDF. But these two things exist separately from one another, and you have to tell the computer to make the PDF. Pretty much any LaTeX development environment will have this feature. So we've written here successfully, hello, my name is Marty. That makes sense. Now, what if I wanted to write a new line? What do people think? What would I do? Double backslash. Oh, you're too good. Can I have somebody who doesn't know the answer? Try to answer the question. Let's say I think, oh, well, I hit the enter button on the code. Certainly this will print to a new line. I am running the LaTeX workshop. No, it doesn't, okay? Keep this in mind. LaTeX doesn't conform to the new line and new paragraphing of the code. It takes its own input. So as you said, thank you. What's your name? David. Thank you, David. David knows his stuff. He knows you have to put double backslash to start a new line. Another alternative. So notice here, there's not like a line break, okay? It's just, hello, my name is Marty. I'm running a LaTeX workshop. If you wanted, you could also put enter between the two lines. And this will also indent. And then notice, more enters doesn't do anything. It's very picky. And then if you didn't want an indent, you'd have to put no indent. That might be yeah, I don't know. Let me look at something here. Hang on. Yeah, that is one way, but I feel like usually, okay, I have document class article, and then like this, below the table. I'm kind of confused, to be honest with you, by the fact that it's indenting here, but anyways, if you want it to indent or not indent, you can always do a backslash indent or backslash no indent, and that will always be fine. So yes, if you want, so let's say, so you can hit 2 spaces, yeah, or you can do, to have a line space, you can do double backslash and a double line break, and so on. Okay, yeah, I'm sorry. Here, let me. You're right. This is not ideal. Here, I think I have a solution. Okay, is that better? Is that? Is that good? I apologize. Okay, so you can set line spacing in the beginning of the document, like before you slash begin document. Sorry. So do you mean like about what the return does? Yeah. So okay, I'll refresh. So we're here, right? This doesn't print a new line. Doing a double backslash, that's a command that tells it to print a new line. Or you can do, instead of the double backslash, you can do double enter. Or any amount where there's a line separating the two lines of code. Like hit the enter button twice. Or sorry, return, whatever it's called on your keyboard. Like this button. You got it? Yeah. Thank you. Okay. And I think, let me look here. I think what I usually do is I usually do at the beginning of my document slash set length par indent 0. Oh, okay, this is why. Sorry, I was usually in my documents, I don't like it to indent. So I always set it to not indent. So I just do, so this is a good, now that we're here, right? This is one of the commands which isn't in an environment. You could do slash set length pair indent 0 centimeters. And this will tell it, I'm setting it, I'm saying your indent should be 0 centimeters long, okay? And then if we do it like this, perfect. This is what we want. Let's say we wanted more space between the paragraphs. We would do, and these are all just commands. At a certain point, if there's a command you don't know of, you just have to Google it. But I'm going over the most basic ones. You can do vspace, okay? And then, like, because it's, a PDF, vspace 3 centimeters. And now it has moved that one down. Does it make sense?
I also saw something like X 5 EM. How does it work?
EM?
EM and EX.
Those are probably different units. Maybe like you can just do 3 and it will do like point. Like if I do 3 point, I don't know what a point is, but you can see it's not very much. Like there's other units. I assume EM is a unit. I don't know. I'm apologize. I haven't heard of that before. Anyways, okay. Everybody good so far? Okay, good. One more thing about how to do text. Let's say you wanted to just put on a new page, somewhat intuitively. The command is \new page. Okay, so this is all very formal. It makes sense a lot. It makes a lot of sense. But you can see here, you're kind of getting the point that LaTeX is super picky. You cannot just like type and then think it's going to put it on the screen however you want. You have to tell it what to do, which is really the disadvantage of it being a programming language. But there are advantages also. Okay, so getting back into the notes. So that's how you do a little bit of text. So writing text here. There's also ways so you can do like a paragraph, right? If you're writing this, if you're one of those maniacs who's writing an English essay in LaTeX and you want to do paragraphs, there's commands for that as well. And as I said here, there's a / no indent that you can do, and so on and so forth. For beginning a new line, this is all good. Yes, and then you can do like, here's small skip, mid skip, big skip, or I usually do just vspace, and sections. Oh yes, and also good to mention, okay, here, so another good tool, which is good to talk about, is subsections. So we have a section introduction and then subsection sub-introduction. And then it's going to put a smaller, oh, I put a new page. I don't want to have a new page. So we have a smaller sub-introduction, and if I remove the numbering, you can see here, it's all going to be inside of that. And you could do sub-section, and so on and so forth. Okay, does any... Pardon? Okay. So it says, there's something that I have done which isn't exactly in the form that LaTeX wants it to be, and so it's yelling at me. It isn't so bad enough that it's giving an error, but it's a warning. This is a warning. So it says, underfull \h box badness 10,000 in paragraph at lines 8 to 9. I don't know what that means. I get that often. You know what badness is in LaTeX?
It's just not full. Like, LaTeX likes you to have it full line.
Right.
But it also doesn't like you to have like a overly full box of things.
Okay.
So usually it means that you didn't like finish the line.
That makes sense.
Half the line break.
Yeah, that makes sense. That's what, I guess that's what the H box means. Right, yeah, exactly. So I'm telling it to start drawing a new line when I only have 5 words on the line, you know? So it doesn't like that. But who cares? LaTeX can deal. And also, LaTeX is pretty good in that if there's an error, it won't stop the code. Like, a compiler will be able to continue working even if there is an error. Okay? So that's all good. Now, let's get into the really good stuff. Okay, so we've seen here a clear disadvantage in some terms. You know, maybe people would argue that this is a good thing, but to be honest, I would kind of prefer that I could just write naturally without having to do backslashes and vertical lines, v-space everywhere. But what is good about LaTeX is the math. Okay, so let's start off with let's say I just want to have inline. I'm running a LaTeX workshop. And 1 is equal to 1. Everybody knows that's true. And I just want to reiterate that in my line. And you can see here, as I said before, this dollar sign environment. I'm establishing a dollar sign environment in the text, and all of the things in it get written as mathematical symbols rather than just text input, right? Whereas when I do this, it's not very noticeable, right? 1 equals 1. There's the math environment layout and the text environment output are pretty much the same, but there is a little bit of difference. Most notably is that, and this is something which is important, so I'll show you now. Spaces in a math environment don't do anything. So if I write a space around my equal sign, it doesn't matter. If you want to, in a math environment, the way you add more space is you write, okay, this is really silly, so I apologize. You write \semicolon, so that will move it a little bit to the right. Or you can do \colon, I think, is a little bit, that's a little bit smaller. Okay, so there's options here. Or you can do, I think you can do \, semicolon. You can do it a couple times, and it'll keep adding more space. Anyways, I encourage you not to get in the weeds about this. Just let LaTeX pick where the math goes. You can if you want, but it's kind of frustrating. Anyways, but this is not a very big. Let's say I wanted a big honkin' equation, right, all across the page. This is not the way to do it because it's in line with the text. But when you're reading your textbook, it's going to have, it'll have the text, and the author's writing along, and then the line stops. And then in the middle of the page, there's a big equation, and then the text begins after, right? How do we do that? Pardon?
Double dollars.
Exactly. David, you read ahead, eh? $2 signs. So when we do $2 signs, it will draw it right in the middle. So let's say I wanted to write like the matrix, like, I don't know, I don't want to confuse people. Let's say I just wanted to write an equation about a vector. So I'm going to use, this is a command also, this is kind of even an environment. I don't know, it depends, kind of gets picky. I think it's a command. So you're going to \vec a, and that draws a little arrow. And let's say I wanted to just write out the position of something, right? Okay, so we have vec a is equal to x, and then for all of these ijk's, I have a little \hat. These are some notations which you might find useful, right? But more importantly, the takeaway here is that if you want to write a symbol in the middle of the page, or an equation in the middle of the page, you use $2 signs. That's most of the time true. But let's say we wanted to have, like, let's say our problem set said, show that this thing is true, and you have to do a bunch of algebra to get from one step to another. Then what would you do? Let's say I wanted to show that it had instead said J, and then I wanted to group the Y and the Z together, right? What would I do to have a new line in my math equation? I would do \, right? Based on what we've done before. Maybe that's a good guess. And then I do this. No, it's not working. I'm surprised even that this worked. But anyways, the point is, it didn't make a new line. You will find that the double $sign, it's the environment for writing out a math equation, but it doesn't have new lines in it. What do we want to do if we want to write a multiple line math equation or set of math equations? This is another environment which you will find very useful. /begin align. Okay? Now, align is an environment which allows you to align math commands down the page. Okay? So, now let's write this in here. And for convenience, let's put the let's do an enter on a code after the \. Oh, I did something wrong. Oh, okay, hang on. So I didn't know that was a package. I just used it so much. Okay, sorry. I am wrong. Hang on. Let me do. Does equation work? No, I don't think this is going to work. Okay, sorry. So in order for me to have to explain the align command, let's use another command. So what we want to do, apparently, there's other ways to do it, but I don't know off the top of my head. We're going to have to use another command outside of the regular document environment. We're going to use centering would work? Okay, I'll try that just to avoid going out of order. Centering. What? Oh, I don't think it. Oh, well. It's okay. I'll just tell them how to install a package. So, what did it say? It said missing package AMSmath. So it has some way. Has anybody here used Python before? That's pretty good, actually. So you know how in Python it's like, and don't worry if you don't know how to use Python. This is not important. This is just an analogy. You know how in Python it's like you're writing along, and then you want to make an array. And you could do it with regular Python lists, but maybe you want to use NumPy, and you use import NumPy. LaTeX has those too, okay? LaTeX also has packages. Like everything in LaTeX, starts with a \, and you just, this marker sucks. I think so. Use package, okay? Use package is the command to import a package. We're going to use this later because this is how you install the graphics package so that you can have pictures in your document. Okay, so use package, and then it looks like the one we want for the thing I want to do is called AMSmath. There's certainly a way to do this that isn't installing a package in Python. I mean, just having multi-line math layout. You could also just write multiple double $ environments, but it's kind of boring. At a certain point, it's kind of annoying. And this is definitely a better way to do it. I haven't actually written it on my thing. Use package amsmath. You shouldn't need to install these, right? It's not like in other things where you need to install the packages directly. I think amsmath and all the other common packages are already installed with any LaTeX distribution or that you could think of. I will show you. Just a moment. So, well, let's start with align. Align star is kind of the special version. Okay, so align. There's numbers.
Oh, okay, so it works the same way.
It's yes, and LaTeX is pretty consistent. If you put a star, if there's something with a command or an environment that has a numbering scheme built into it, and then you push the star button or asterisk, there's a good chance that it will not write the number if you do that. Okay, so, and here we go. Okay, this is perfect. We have our two things, and we can write and we can do the double backslash. Now, one thing, let's say we wanted to do 2 lines, but I'm a real double return guy instead of double backslash. Oh no, there's an error. If you are going to write stuff in the align environment, you have to have every line filled. You can't have an empty line. So unfortunately, you have to write double backslash to enter. You don't have as much flexibility. Now there's one more thing to point out here. Let's say, okay, that I just had an uneven number of amount of text on each line. Well, look at this. Now the equal signs are off, okay? But in any good math equation, you want to line the equal signs up. What are we going to do? Well, let's do it like this, okay? This was my original example of why you might want to do this. So if you're in the align environment, you can designate a character to be, yeah? Oh, I'm sorry. This is really, surprise, surprise, overleaf is not designed for presenting on a screen. Can you look at what is going on here? This is ridiculous. Okay, I have to, oh, you can drag, oh. I know, but then I do this so that how's this? Oh no. Is this good? Is this better? Well, I mean, but the left side is more important? Is that enough? Is that big enough? Okay, good. Oh, I'm sorry. It's too much stuff. I'll try not to go out of order. No, you're right. Oh my god, this is ridiculous. Oh, this is kind of working now, okay. Oh, this is good. Got it dialed in, okay. So, what have we done? Let's recap the last 10 minutes. We started wanting to write multi-line math expressions, like we have here on the right, okay? Now, in order to do that, I found, the LaTeX started yelling at me, that in order to use the program I wanted, in order to use the environment I wanted to use, you had to install a package. So, I used what is a package? It is a separate set of tools which LaTeX can use, which aren't, built into the regular set of default instructions in the language, but which are commonly used. So they're a separate, cordoned off, group of commands which can be imported and used at will. And in order to start using those, in order to be using those in a given LaTeX document, you have to use /use package. And in this case, the one we wanted is amsmath. Okay. Does that make sense? Compiled. Yeah. No, it has to be. This is what I mean. So this is what I meant about how there are some commands which go inside the document environment and some commands which don't. So use package and also set length. These are commands which go outside of the document environment. And if I brought use package into the document environment, there would be an error. And then it all goes wrong. It looks like it still works. No, it doesn't. It starts yelling at me. Okay, well, that's expected. So why exactly does the use package have to be at the beginning? Because the people who made LaTeX decided that this would be the most easiest way to lay out the program. There isn't really much to say about it apart from that, unfortunately. You just kind of have to learn the way of things. So there are a number of commands which, if you want to use them, you have to put them outside of the begin environment. But in general, the commands which go outside of the environment or of the document environment, they are going to be things which you would want to happen before you start drawing to the screen. So on each time LaTeX compiles the PDF, it is going to start, it is going to want to load all the commands it's going to be using. It is going to want to know what are the different, formats and structures I'm going to be using in my document. It wants to know all those things before you start writing. Okay, so this all makes sense. Everybody understand? Oh, the VSpace, it's like, remember I had said about, so, you can do a double backslash to enter a new line, or you can do a double return. But if I wanted to do more vertical space between paragraphs, you can just do \VSpace, and then that like artificially includes more, it just moves the stuff below it down. You can put, it's just it'll take any unit. Like it'll take like 4 centimeters or 3 point, like font point, So whatever kind of units you want to be using for your document, it'll take that, but it has to be a number and an amount of distance. Anybody else? Any questions? Unfortunately, we do have a lot to get to, so I apologize if I'm moving a little quickly. Please stop me and interrupt me if there's anything you don't fully understand, okay? Good? Perfect? Good? Okay. So, back to business. What do I want to do? You can see the equal signs are unaligned here. What do I want to do about this? In the align environment, and I think this is really useful, you put an ampersand beside whatever character, and then align will line them up. Let's say that I wanted to align along the equal sign in the first line and along the plus in the second line. Then you can do it. Okay, so it's not just the equal sign. So it's very, very good to use for writing these things out, okay? And then, let's say I wanted to write 2 sets, like going down the page, like 2 sets of equations, okay? Plus, let's say this was k's instead. So what have I just done? We have our /begin, and as you've seen, in general, although this is not always the case, as with the dollar signs, but it is most of the time the case, that if you want to start an environment, you just use \begin. So we have said \begin align. Okay, and then at the end it has said /end align, like how we have /end document, right? Pretty self-explanatory, except for how weird it is. Okay, good. And then I have wanted to write, I have an equation here. And then I have an equation here. And I have used the ampersand to align them. I have placed the ampersand symbol next to one of the symbols in either of these equations to align them along those symbols. What have I just done? Now here's another thing you can do. You can place an ampersand out on its own after this equation. What does an ampersand look like again? I have to draw one. Okay, it's like this. Okay? And then you have another equation. And then you have your backslash. This is going to draw this equation off to the side in a separate column. And so you can see here. This is what that outputs. Does that make sort of sense? Yes, yes. So you're around one step ahead of me. So this sort of, as is often the case, and then I'll get to your question. As is often the case, LaTeX, in this way of laying out tables and sets of things in a graphical environment, it uses across the language, a common language for how are we going to lay these things out. So, in an array, you have line by line, each element in a row is separated by an ampersand, and each time you want to end a row and start a new row, it's separated by a double backslash. So, let's see another example of this. Sorry, but before that, you had a question. Oh, so as I said, I know it's a lot to go off of, but like I had said, a line has numbers. Each line is numbered. Pardon? Oh, so you want the first line, you want text in the math? Yeah, but then you want here, let me see if I can understand your question here. I think I know what you mean. So it looks like this. Okay, yeah. So you don't want a number here, but you want a number here? I don't believe there's a way to do that in this environment. Yeah? Well, yeah, you could just do another, in one align environment. Yeah. Yeah, so exactly. That would work too. Yeah. So the question was, how do you have it so that you have a line, like a number here, but no number here, for example, and in a single use of the align environment, that cannot be done just because of the construction of the program, but you could just put in as well. You could just also, there's another way to do it. You could just end and then begin another align environment, but make it an align star. And that will have it like that. And then, okay, let's say we didn't want this space. Potentially what we could do, what are we doing for time? We're a little bit behind time, actually. So there are ways, like if you wanted to reduce the vertical space, you can actually give v space. We talked about v space. You can give it negative distances. and it will subtract distance. Okay, so that's something that you might want to try out on your own time. We're a little bit behind schedule though, so I want to keep chugging along on the math stuff here. Okay, so this is all good, and we have a good understanding of how can we lay out multi-line equations so that the equal sign or whatever symbol is lined up, and how can we write these out so that we have, for example, two equations beside each other, and in a way where we don't have to type backslash semicolon 30 times. Okay, so this is all good. Let's see another example, something very common. How many of you guys are taking a linear algebra course? Nice. Well, Andy's taking linear algebra. Okay, so you guys might find this useful. I don't know, I think it's P matrix. Do you remember the command? Is it? Yeah. So so I'll show you in a moment, but P matrix is another environment similar to a line, which instead of it laying out, arrays of equations, it does matrices. A, B, let's just write out the identity matrix, okay? And we're using that exact same logic as we had just discussed. The issue is that it isn't, so I was just about to say this, but so notice here, when I fire up, it is saying missing $ inserted, okay? So what does this mean? So I am putting matrix here, the matrix environment, outside of any math environment. And the thing is firing up at me and it's saying missing $sign inserted. So what we can tell from this is that the matrix environment actually doesn't belong outside of a math environment. The matrix environment is a type of environment which should be written in another environment, which is kind of odd, but there's many things like this. So let's say we write it in, and then we do and equals to 1, which is not really true, but sometimes. Okay, and here we go. Our matrix is a matrix, right? And it's written into the align environment in a way such that not only can we lay it out properly and it looks all nice, but we can also have it with the equal sign there lined up with the other texts. Because it's not really, like I said, it's just that it gives you back whatever vector you put into it, which is kind of what 1 does. Yeah, I'm just trying to lay it out. I apologize. What? Oh, well, why didn't you tell me this? Come and fix it. Oh yeah, my scrolling is backwards. Oh, that's really good. Thank you, Rui. Nice. Well, let's give a round of applause. Okay, so this is all good. Oh, shoot. Whoops, I hate it when I do that. Now, what if we put, instead of P matrix, okay, P matrix, you can see it has parenthesis. You know what I'm going to do even? This is probably a little bit, I hope this doesn't break it. Oh, wow, that's me. Wow. Okay, and then I'm going to put it here. Does this work? Yeah, it's just that I want to have, well, I don't know. The being connected to the TV is kind of making my graphics scaling weird. So anyways, let's say, so that was that was parentheses matrix. It had the rounded edges on the side, and B matrix has brackets on the side. Okay, so this is all very good. Does anybody have any questions about this? About this style of laying out a math environment? No questions? Perfect. Okay, let's go back. So I wanted to, there was a couple more things that are good math commands to know, but I just wanted to make sure we're not too, because we have some other things to get to. Oh, my computer's gonna die. Oh, well, it should be all right, but better safe than sorry. Oh, I forgot my charger at home. Well, hopefully that doesn't die. Oh, we should be okay. I have plenty. I have 17%. No, it's okay. I should be good. Okay, this looks all good. Yeah, so there's some more stuff. Yeah, we're all good. We're making good progress here. We're making good progress here. Oh, thank you. I mean, it's really okay, but you know, I was just gonna. It doesn't really.
Just continue.
Okay. So I want to come back at the end and tell you guys some other useful math tools. But before then, something important to discuss. So I want to talk about how do you include images. Oh yeah, we're good. Thank you. Thank you. So to include images in a LaTeX document, you have to use the \use package, okay? And it is the graphic X package. So everybody use \use package graphic X, and then let's pick an image. What image do people want to put in our LaTeX document? I know, but it might be here. Is this good? Oh well, we love Edgar. He's the Physics Student Union social coordinator. You know, why him? I don't really know, to be honest with you. It's just something you don't ask. Okay, Edgar. And then, okay, the graphic X package has allowed us. There's something I just did which is a little subtle, so I'll get into that in a moment. But in general, the graphic X package has allowed us, I have to rename the picture, has allowed us to now use a command called include graphics. And then in the squirrely brackets, oh, yeah. Sure. Is that good? Okay. In the squirrely brackets, we write the name of the image. So I have named it edgar.jpg. Okay. And then when we hit recompile, there he is. Okay. Now, let's say I wanted to make it a little bigger or a little smaller. So the include graphics command, it has the main arguments, which go inside the squirrely brackets, but there's also other separate, like kind of optional arguments which you can put. And to use these, you have to put square brackets. Okay, so as you can see, putting those hasn't changed anything. But now, let's say I put scale equals 0.8. Does anybody want to make a guess about what this is going to do?
Shrink it in size, 80%.
That looks like 80% to me. Okay, good. And then let's say we wanted to have it really big. 200%. Nice. Okay, perfect. There's one more.
Do it in the local editor, because now you have Overleaf and you upload the JPEG file to Overleaf.
I was just about to say, you can't confuse them, you know. Yeah, but sorry, go on. I'm just joking. Yeah, okay, how do you do this in a local editor? So what he's asking about is, so notice when I downloaded the image, I put it here. Like I said, Overleaf has, not only does it have a LaTeX compiler, not only does it have a text editor where you can, write LaTeX code and it'll like recommend what you want to type, and it'll color everything. Not only does it have these things, it also has a file storage, online file storage. So in this LaTeX, or in this Overleaf project, I have put edgar.jpg, the file, which I have just downloaded off the internet. He's asking if you have a local, not Overleaf LaTeX software, like, for example, TechMaker. How do you do this? And what I do is, there's probably a better way to do this, I don't know how, is you just include in the same directory as your LaTeX document, or sorry, as your LaTeX file, like the .tex, you just include the file there. You know what I mean? So let's say I had like,
Oh, so you put it in the same
yeah,
folder. So you basically, for example, if it's in a local editor, you put edgar.jpg into
yeah,
the same folder as the text file.
yeah. So
And then
let's
you just
say
include it in.
I have on my computer this is my desktop. I have school stuff, and these are the courses I'm taking. And then in problem sets, I have like, I don't know. Okay, well, it's not on this computer. I don't do my LaTeXing on this computer. But let's say I just had the problem set, like a folder for my problem set, 1. And then I have my tech document for laying out problem set 1. And then I had inside also, like next to it in that directory, I had the images that I want to put in. So like, obviously, putting a picture of Edgar is really silly, although not to say that it isn't useful. But if you are like writing a lab report and you make a plot in Python, right? You like make a figure, and then you want to include it in the package, or include it in the PDF, I mean to say. This is exactly how you would do it. You have a question? Okay, sorry. You have a question?
How do you make it center?
I was just about to say. So there's one environment we haven't gotten to, which is called begin. Obviously, you have to say begin. That's how they work. Center. Okay. So what can we do? We can just put this command in the center environment, and then it will be centered.
How do you label it, for example, figure 1?
So this will be covered more in the next workshop, but there's a figure environment. And then, okay, so
But it doesn't get labeled.
so that's, I have, so you can do, okay. I think you can do begin center, is it, or slash end, and then like this. Okay, and then I'll get to the labeling. Okay, okay, that's good, that's good. So, oh, it's not centered.
Yeah, it's not centered. You don't want to use
Never mind. Rui's right. This is gonna work. Okay. Yes. So okay. So the figure environment has its own extra stuff. And then how do you label it? I think you do / label, and then like this is PhySU VP Social. What? But I did a / label. Oh, oh. Oh, okay, okay, okay. Oh, oh, so you want to have / caption in the environment. That makes sense. Oh, so you should do like / centering / caption, and then you should do So that's how you do it. You do so the figure environment has a caption command, which allows you to do that. And you can do, so let's say I do /label. Okay, this is something I do know. I basically never use this function. I know, eh? /label Edgar. Okay, and then you can do, what does that mean? Right, well, last time we did the /label, it didn't do anything. You can do /ref Edgar. And then, let's put it in the sub introduction. Who is Edgar? /ref Edgar. And then we click this 1 here. So it's referencing automatically to figure 1. Yeah. So yeah, if we want to have it be a hyperlink, we have to have it like that. Anyways, we're kind of getting off the rails here. So let's get back on. Runaway argument? What are you talking about? Don't worry about it. This will be covered. This all is what's going to be in the next workshop. So don't worry about that. Yeah. It's like I was trying to show it, but I didn't do it right, and I don't really know how to do it. So it's like, you ever read a paper and then there's like a little red box, and then you click on it and it takes you to another part of the PDF. That's what that is. Yeah. But essentially, it's just sort of LaTeX built-in referencing and citation stuff. Do you have a question? They will be covered in the next workshop in detail. It's not as much material for today. Late figuring and citations will be covered in more detail in the next workshop. It's just a question about it. Yeah, well, so that's what I was gonna say is, as you can see, it's like not in the right spot, and that's kind of one of the annoying things about it, is that LaTeX will disagree with you on where this figure should go on the page, and it will start fighting with you, and it will just put it wherever it wants. So you have to, there's like ways to do it. Isn't it like !H or something? Oh, shoot, not acorn. Okay, so it's not exactly putting it, oh, unknown float argument. I think it's !H. We shouldn't really be talking about this. This is not, that's the right one. Okay, so like I said we were doing the include graphics, right? And you can see here that next to the include graphics, there's some little square brackets with scale, like a special keyword argument that we're adding to the include graphics command to give it extra details on how we're going to run this command. We can do exactly that same thing with the figure environment, and then the square brackets !H tells it to put it here on the page, wherever your code says to. Does that make sense, everybody? But again, this is kind of, we're really skipping through here. This isn't meant to be in this workshop. I'm just reacting to the will of the people, so it's the crowds. Okay, so this is all very good. Let's put this on a new page. And so everybody understands about how the important thing is that you can just do include graphics, and then you can include a picture. That's really the essential thing. And if you want to have it centered in the page, you can do /begin center. Okay, and then you can put the command to include the graphic in the thing. And now, if you want it, you can have it all on one line too. Is everybody following along at this point? With the figure environment. So the figure environment, like I said, LaTeX has its own opinions on where a figure should go in the document. I think if you just do /include graphic, it won't do that, like outside of the environment like we had originally. But yeah, if you do the square bracket exclamation mark lowercase h, it will more often agree with you on where it should go in the document. But this is really advanced stuff for the first lecture, or for the first workshop, I mean to say. So we're going to be talking more about it in the next one. Okay. So this is all good. Let's go over now. There's a couple more useful math items that I think would be good for folks to know about. Other stuff I have here. I have here something I pulled off of the internet. How do you do, let's say I wanted to write an equation. Okay? I wanted to say I have a function. Okay, I have a function. And it has a certain value. Let's say it's valued 1 when x is greater than 1. And then it's valued 0 when x is less than or equal to 1. Okay? Pretty normal case, right? Especially if you guys are taking like an electricity and magnetism course or something. Lots of cases where you're going to want to define a function piecewise, okay? So how do you do that in LaTeX? Not immediately obvious. How do you make a like this squirrel bracket here that covers multiple lines? Okay? Here's how you do it. It is the cases environment. And again, like matrix, cases is included in a math environment. Cases is a type of environment that belongs in another math environment. So here's an example. I'll just write out what I had on the board. So you can see here we have written in our code this piece of text here, okay? This piece of command. And then it's translating over and it's getting formatted into this stuff on the PDF. How is it working? So here's how you use the cases environment, okay? So we are going to say in our math environment, whatever that may be, it could be a line, it could be $, right? What we've discussed in this, a lot of ways to create a math environment. This is just one of them, whatever one you want to use, but I'm just going to say $, okay? And then you have your thing f at x equals. That's just this part, okay? So before you get up to the cases bracket, nothing is different, okay? And then once you get to this part, you have to do \begin cases. And \, of course, because we always need to end our environment once we start it, we're going to put at the end \end cases. So, and then of course, because also we need to end our $signs. So that's what we're going to write to get it in this form. Does this make sense to everybody? Now, once we are here, we want to write these things. And like with everything else that we've done so far, when you want to write out in LaTeX an array, you use the same syntax, which is the ampersand for a horizontal separation and the backslash for a new line vertically. So we have here 1. I can't draw. I don't remember what an, it's like you don't remember what an ampersand looks like exactly when you want to write one. Okay. All right, so it's like this. Okay, 1 and x is greater than 1. 0 and x. How do we write this thing? Okay, this is just another command, which is good to know. The way you write a greater than, or the way you write a less than or equal to sign is you do backslash LEQ, okay? Backslash LEQ1. And again, at the end of each line, you want to put a double backslash to tell it. So we're starting in our cases environment. We start with the top left. We give it an ampersand to tell it we want to go to the right, and we want to put our condition. Then we do a double backslash to go to the next line. Then we put the 0, and so on and so forth. And we could do more with more double backslashes if we want. So, for the most part, that's pretty much it. It is, I think we've gone through a lot, so I would encourage you guys to maybe try some out on your own now. Like try writing some different equations that you might want to represent. And maybe you'll have to Google. So here, I'll do a challenge for you. Let's do a big one. I don't know. What's a good equation that could be written? Like, I don't know. What'd you say? I don't. Why is this? I forgot about what that is, but yeah. This looks good. This looks good. Okay, yeah. So here's this. Okay, let's try writing this out. It's a good lesson to have to Google how to do something in LaTeX. But don't worry, we'll take this up in a little bit. So okay, so it says z equals, and then there's this summation here. And then you want to do e to the negative beta e sub I. Okay, here, I'll get you started because there's some things here. There's actually a lot of things here which I haven't told you how to do, I suppose. So the way you write, you write slash beta to do a beta, okay? To do a subscript, you do an underscore. And to do a superscript, you do a chevron, like a small uptick arrow. Okay. How are you gonna write the sum notation? You're gonna have to figure that out. Okay. That's a Google. That's a Google. I will write the correct answer, and then don't look. Yeah. What do you mean? Oh, I know. Just don't look. Just don't look. I don't understand what you mean. Here?
After I, yeah.
Oh, around the sum?
Yeah.
I don't think you do.
You don't need it. The underscore takes in the first element afterwards. Oh, only take first element. Yeah. So if you wanted to like have multiple characters and the
Mhm.
you will have to add. Oh,
Yes,
yeah.
then you have to add it. But let's say I wanted, because we're really taking away from the don't look thing here, but let's say I wanted to have multiple characters in the subscript, then I would do a yeah.
Same thing for color.
Yes, exactly. Same thing for the exponential. Okay.
Very clean.
Oh, thank you.
Like when you do a label,
Mm-hmm.
you need to define whether it's a figure or this one is a figure. Big colon, whatever. And for equations, you label as
Yeah, I never do that. I just don't think it's. I don't know. I don't like it that much. Yeah, but I said I have a skill issue, as you say, so I don't do that. Quite large. Has everybody made good progress on this? So you've learned how would I do it? How stupid. How to write a sum notation in LaTeX. Wow, this is a common question people have. Okay, you go here, and then, oh, it wants to show me an integral, okay, and then you here see it says LaTeX code for this \sum underscore n equals 1. So we can see from this, it does seem that way, that when you do \sum, it's like a special kind of character where the subscripts get put underneath the sigma and the superscripts get put above the sigma. Okay? So let me look to see if there was anything else I wanted to go over. Oh, it's the partition function. Sorry, it's right here. It's just this. Don't worry. It's a statistical mechanics thing. It doesn't really matter. Mm-hmm.
So I put the sub I.
Yeah, it should work.
It's putting it on the bottom right.
I think if you put it in the cases, it likes it so sometimes when you put it in the certain environment, it won't let it be the full size, and so it'll put it down, you know. It'll make it a smaller. So take it, or here I'll show you. So instead of writing out like I've written here, this is what I've written. Z is equal to the sum underscore I times, I'll put a space there, e to the this thing, negative beta e to the I. What if I put instead, because this is this sum notation, that's just the letter sigma. What if I just put sigma instead? Oh, shoot. Okay, well, that's the lowercase sigma. We want the uppercase sigma. How do we write the uppercase sigma? That's generally true for Greek letters, but it's small, okay? So that's what's happening, I think, to you. It's like, because it's in the cases environment, he's writing it like it's as if what he's doing on his screen is like if I had written this here. Okay. That's not really what I wanted to write, actually. Okay. Doesn't really make any sense, of course. But let's say I want to put that there. So what he's saying is like, if this is a sum, then, it's not writing the I underneath. And that's simply because the cases environment doesn't allow you to write it out, because it likes it to be small inside the curly bracket, and so it just doesn't like you to write it out with such, like with the full height. Okay, let me see. So was there anything else? So I'm just going over some useful math tricks. Oh, very good, very good. So how do you do fractions? That's a very good suggestion. Okay, so in math here, how do you do fractions? You do backslash, yes. Frac, and then, so there's two sets of squirrely brackets for this one. So let's say I just wanted to do 1/2. You just write the numerator in the first set of brackets and the denominator in the second set of brackets, okay? And then you write a 1/2 there. So this is all very good. Oh, yeah. So this is good. This is good. I think this is good. I think this is going well. I don't know. Okay, so let's say here I wanted to write, for example, just as an example, the partition function like we have been talking about. And then instead of doing that, I could write this. Okay? So, how do you do, let's say I want to do parentheses in a math equation. Okay, so I want to do just like this. Obviously, with most characters that are on the keyboard, you can just use the parentheses in the math environment. But it seems like, okay, for some reason, the parentheses aren't reaching the full height of the math object that they're surrounding. So how are we going to make that happen? What you can do is you can just do /left, open parentheses, /right, close parentheses. And then it will fully surround whatever you're typing around, okay? So there's also ways to do this. There's like big parentheses. There's other, so you can Google if you want other ways to do this. And this will work for all types of parentheses or brackets.
Then if you only add brackets, it doesn't work.
Like these? I think it does. Yeah. Yeah, they're just smaller ones. Like it's just like with the parentheses.
Oh, so for large equations, smaller equations.
Yeah. Like if we had written it the old way that I had been writing this partition function. Did I just do Control F? This is really man versus the machine here. Okay. All right. Let's say I just wanted to write it like this. So in this case, the regular square brackets are probably fine, you know? This makes sense like with what we said above, you know, we were using these and it was totally fine. In this case, for these vector equations, totally good, okay? What? I don't know what that is.
So it's a website for like finding latex signs.
Oh, I see. I know what that is. Oh, there is one more thing I should show you guys. Let's say you want text in your math equations. Okay, so in the middle of this, we want to say, so if you're in a math environment, you can say \text, and this will not represent it in math. So it's like you've fully gone full circle at this point. So you've started a math environment, you're writing math, and then inside the math environment, you go back to a text environment. And you can say this is a normal text. And then it is written normally, even though this is in a math environment. Okay, so these are all very good things to know. Now, what Rui is talking about here is a website called Detechify. Okay, so this is a website where you draw on this little box, and then it'll tell you the LaTeX command to draw that symbol. So let's say I want an alpha, and it'll recognize it. Oh, it thinks I mean proportional to. Well, that's also fine. Yes, and it'll say \alpha \prop2. Okay, so these are all good. Okay, I think we're going to end it there. It is 6:57. So I hope today we've given a good introduction to how to add sections, how to do text, and how to write out just regular plain paragraphs and whatnot in a LaTeX document, and how to write out math. So and how to include figures, how to include pictures. So for the most part, for writing out a problem set, I think this is all you need. Okay. Next time we will cover how to make tables, as well as how to do citations a little bit, and how to do figures, how to actually do the referencing, and all of those things, which personally I usually skip. I'm a bad student. I don't do citations, so I don't know as much about that. But okay, this is all very good. So does anybody have any final questions? Mm-hmm.
The I isn't below the, like I've tested like
Oh.
the limit of the it just doesn't work. So did I not?
Oh, it's because you have the single line math. So remember we were I know it was 2 hours ago, but remember we were talking before. The single dollar sign is like in line with your text math. The double dollar sign is like separate line from your text. Yeah. So if you do a double dollar sign at the beginning and at the end, then it will work. And this is like what we had talked about before. So if it's in a math environment which is too small to fully represent what you want to type, it'll just kind of smush it in a little bit,
Because it was like
Yeah, exactly. Yeah, like a normal subscript, and that's why it's doing that.
Also, I just put like some of them can't see.
No, yeah, I know, yeah. I didn't really.
Yeah, but it's just
I should.
I was just playing around accidentally and I pressed the button.
No, it's good. I can't really do that. I don't have a mouse, but I wasn't. Yeah, I'm not sure. Anyways, I think Rui's suggestion worked out though for the most part. So, okay, we're now going to end the live stream. Okay, so goodbye, computer people. Nice to see you all. Thank you for sticking around. Anybody who was in the chat, I have a good day. I don't think so, Andy. I don't think so. I didn't announce the live stream at all, but I did record this.